Hello, this is Ms. DB, and today we are going to go over how to do Chapter 3, Section 2, which is when we have parallel lines cut by a transversal. We're going to look at what happens to all of those angles. So first of all, this is a review from yesterday's, or from 3.1. So you should be able to tell me angle 1 and angle 3. You should be able to tell me what you would call those. What would you call angle 3 and angle 6? What would you call angle 4 and angle 5? And what would you call angle 6 and angle 7? Assume that, that this is the transversal right here, T. Okay, so you go ahead and answer those and then check your answers. First one should have been corresponding angles. 1 and 3 are corresponding. Number 3 and 6 are alternate interior angles. Number 4 and 5 are alternate exterior angles, and angle 6 and angle 7 are same side interior. Our objective today is to prove and use theorems about the angles formed by parallel lines in a transversal. There's also a postulate there. Here it is. Here's our postulate. The corresponding angles postulate says that if two parallel lines are cut by a transversal, which in this picture is T, then the pairs of corresponding angles are congruent. So angle 1 right here corresponds to angle 3. Those would be congruent. Angle 6 corresponds to angle 8, and those would be congruent. Angle 2 corresponds to angle 4, and they are congruent. And angle 5 corresponds to angle 7, so they are congruent. Also note that when you have parallel lines, they put an arrow on the parallel lines, on each one, to show that those are the parallel lines and then the transversal is the other one. Okay, we're going to use the corresponding angles postulate to find some missing angles. We want to find the measure of angle ECF. So here's E, here's C, that's our vertex because it's in the middle, and here's F. I want to find this angle right here. And the way I do that is I see, well, I could use the corresponding angles. What would this correspond to? It would correspond to angle EBG, which is given as 70 degrees. So we can use this corresponding angles postulate to know that our angle is 70 degrees. The measure of angle ECF is 70 degrees. Okay, let's find the angle DCE. Let's get a different color here. DCE is up here. There's more than one way to find this. We could say that this would be congruent to angle ABE because of the corresponding angles postulate. So then we could write that 5x equals 4x plus 22. Then we subtract 4x from both sides to get x, or 1x, equals 22. Now that's not our answer because we wanted to find the angle of DCE, not 22. So we plug that back into the expression of 5x, and we'll get 5 times 22, which is 110 degrees for that angle. Now some of you may have said, wait, couldn't I just use the fact that these two angles here are a linear pair? So if I already know that this is 70, I could take 180 minus 70 and get 110 degrees for angle DCE, which is the same thing. So there's often going to be more than one way of doing these problems, of finding missing angles. Okay, this one asks you to find angle QRS. That would be this angle right here. Now, interestingly enough, I don't know its corresponding angle would be over here. I don't know any measure about that. However, I could find that measure, angle, I don't know what it is, but I could take a linear pair is 180 minus 118, find that measure. Oh, sorry. No, but yeah. So that's 118 right here. This x is 118. But then I still have to take 180 minus 118 to find the measure of angle QRS, which would be 180 minus 118 is, there we go, 62 degrees. I went too fast. So 62 degrees. So we could find x first and then take 180 minus x, or we could do what I was doing and say, let's take find the measure of its corresponding angle first and then find that it's equal to that. So if a transversal is perpendicular to two parallel lines, all 8 angles are congruent. So parallel lines are shown with that little arrow on them. Perpendicular lines are shown with a little right angle mark. In this case, all of the angles would be congruent, and they'd all be 90 degrees. All right, so the postulate, the corresponding angles postulate, we just accepted to be true without proof, but now there's going to be some more theorems, and we need to prove them. And we can use the postulate we just learned about to do that. Any postulates, definitions, or previously proven theorems can be used as steps in our proofs. Here's our theorems. The first one is the alternate interior angles theorem, which says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So this angle, angle 1, would be congruent to angle 3. Angle 4 would be congruent to angle 2. And the next theorem, the alternate exterior angles, if you have two parallel lines cut by a transversal, then the alternate exterior angles will be congruent. And same thing with angle 6 and angle 8. Now this one's different. So when you're writing these down in your notes, make sure that you see that same side interior angles, also called consecutive interior, they're not equal to each other. Let me say that again. They are not equal to each other. So the way this works is that the two on the same side will add up to 180 degrees. So angle 2 plus angle 3 is equal to 180. Also, angle 1 plus angle 4 are equal to 180. They're supplementary. They are not congruent. Not congruent. Make sure that you realize that their measures will not be equal because these are not congruent angles. This is just a hint from a student from your textbook. It says, when I solve a problem with parallel lines and transversals, I remind myself that every pair of angles is either congruent or supplementary. So all of the small angles, the acute angles, will be congruent to each other, and all of the large angles will also end up being, the obtuse angles will be congruent to each other. So if you only know one angle, you can find all the rest. If you know this angle is 50 degrees, all of the acute angles are 50 degrees. And if you know that's 50 degrees, then you know all of the obtuse angles can be found by taking 180 minus 50. So all of the obtuse angles, the big angles, would be 130 degrees. So if you know one angle in a problem where you have two parallel lines cut by a transversal, you'll be able to find all of the other ones. Here's the proof of the alternate interior angles theorem. The other two proofs will be, they're problems in your book. One of them will be on your worksheet completed, and one of them will be for you to finish. All right, so we are given that angle L is parallel to angle M. That's what this means here. It means L is parallel to M. So I can write that down. L parallel to M, that's given. This is a flowchart proof, it's called. So we start with our given, and then from that, what do we know? Well, if they're parallel lines cut by a transversal, then I'm already learned that the corresponding angles postulate, I assume that this is true, will be showing that angle 1 will be congruent to angle 3. So that's what we write down here. Angle 1 is congruent to angle 3. That's because of the corresponding angles postulate. All right. Also, because we have parallel lines cut by a transversal here, we have some vertical angles in our picture. Do you see the vertical angles? Angle 1 and angle 2 are vertical angles. So I can write that angle 1 is congruent to angle 2 because we learned already in, I think it was in 2.6 or 2.7, that vertical angles are congruent. That was a vertical angles theorem. I don't remember the exact number, but it was from 2.6 or 2.7. So the vertical angles theorem says that vertical angles are congruent. So now we have angle 1 is congruent to angle 2. We also have angle 1 is congruent to angle 3. So I can use the transitive property to kind of jump over this part. It's the same for both of them. And I can say that angle 2 is congruent to angle 3 by the transitive property of congruence. And remember that I wrote it right. That's what we were trying to prove in the first place, was that angle 2 is congruent to angle 3, because that proves that the alternate interior angles are congruent. So we just proved that alternate interior angles are congruent. So now we can use this theorem in our future proofs if needed. We can also use it to solve problems now. So let's use either the alternate interior angles theorem, or the corresponding angles postulate, or same side interior, or which one did I skip? Consecutive interior? No, I said that one. Alternate interior angles are congruent. We'll just use whichever one we need. The measure of angle EDG. Find that angle. EDG is this one. We want to find that. Well, let's see. I could use alternate exterior angles because it is an alternate exterior angle with angle FBC. So that means that x minus 30 is going to be equal to 75. And that's all I need to know. I don't even have to find x because they just wanted to know that it's equal to 75 degrees. Now the next one is angle B. Let's see, BDG. Where's B? BDG. Okay, that's angle X. Well, I can find X because the alternate exterior angles theorem says that x minus 30 is equal to 75. I add 30 to both sides, and I'll have that x is equal to 105. And this x and this x are the same. Every time they use a variable in a problem like this, all the x's are the same thing. They would have to use a different variable if they wanted it to have a different value. You could also have solved this one, letter B, by adding these two together to get to 180 because they are supplementary. So if we didn't know that the exterior angles theorem said that these two were equal, I could have done this. I could have said 3x minus 135 is equal to 180. So again, there's more than one way to solve most of these problems. And you can use all of your skills and techniques from before in order to solve with whichever postulate or theorem that we've had before, or definition. Okay, here's another problem. It says find the measure of angle ABD. So first and foremost important thing is that you know what angle they're looking for. They're looking for this angle right here. Now it's quite tricky to see what 2x plus 10 is referring to. It is referring to this angle, and this one is referring to this angle. So they should have arrows pointing to that or some way telling you that. They don't, but they should. So you would say that alternate interior angles are equal to each other. So you should be able to say 2x plus 10 equals 3x minus 15. Now we need to solve for x. So you can subtract 2x from both sides. And that would give us 10 equals x minus 15. And then add 15 to both sides, and you'll get that x is equal to 25. Now that's x. Again, that's not our final answer because now we need to take it and plug it back into this expression because that's what angle ABD is, the expression for that. So then you get 2 times 25 is 50 plus 10 is 60. Now you have your final answer. Okay, one more example. It says it's a music application, but we just really have a picture here. I think it's supposed to be strings. So we have find the measure of x and y in the diagram. So we have 3 parallel lines cut by 2 different transversals. These can be quite tricky. The key here is to pick the 2 parallel lines first and the transversal that lets us answer at least one of these parts. So I'm going to say that this is my transversal, and the two parallel lines are the blue ones here. So 60 and 50 are corresponding angles. I'm not 50. 60 and 5x plus 5y are corresponding angles. But that's a little tricky, isn't it? Corresponding angles are congruent, so I can write that down. I guess I'll start with that. Now, let me get a different color. What if I used these two parallel lines cut by the other line for a transversal? What do we know then? Not much. We know 55 is this one and 60, but one's, oh, they are exterior. No, that's not right. Oh no, 60 is not part of it because I didn't use the green lines. So 55. Yeah, that's not going to help me out any because I only know the 55. So let me erase this one. I'm going to keep that 55, that first green line, and I'm going to change to this green line. I'm going to ignore the one in the middle. And I'm going to use, which transversal would give me some information? The top one again, I think. Now I have that 55 and this measure, which is 5x plus 4y, are equal to each other because they are alternate interior angles. All right, let's look at the steps for this one. This one's a little tricky. So there we've got the 5x plus 4y equals 55. We also have the 5x plus 5y equals 60. We have two equations and two variables. So this is system of linear equations, which was probably your favorite chapter from algebra, if you remember that. What they're saying is if I multiply everything on the bottom one by, say, a -1, let me change all of the signs then, and then add these together. Actually, I bet you they added, bet they did the negative on the bottom one. I mean, in the top one. So I'd have -5x plus 5x is 0, -4y plus 5y is 1y, and then -55 plus 60 is 5. So now I have the value of y. Once you have one of the values, then you can substitute back in, and you can find the other one's value by substitution. So you can pick either expression to substitute it back in for. They chose just randomly 5x plus 5y equals 60, replaced y with 5, finished solving, and they got x equals 7. So to finish solving, you'd have 5x plus 25 equals 60, subtract 25 from both sides, and you get 35, so 5x equals 35. And then you can see where they got the 7 from. Divide by 5, x equals 7. So y was equal to 5, x was equal to 7. That one's a little trickier. Okay, well, I hope you learned a lot. If you have any questions, please ask for help. Come to my office hours. Go to the ASC room whenever it's open and get assistance on whatever you need help with. Thank you very much.